Let's talk about direct substitution. Direct substitution allows us to evaluate a limit by simply plugging in the x value that we're approaching. In this example, we plug in the 1, 2 times 1 squared minus 3, that's 2 minus 3 or negative 1. Now there is a caveat with direct substitution. In order to use it, we need to make sure that the function is continuous at the x value our limit is approaching. So what we'll see is that if the function f of x is continuous at x equals a, we know that the limit of f of x as x approaches a would be equal to f of a. Now we haven't gone into detail on continuity, that'll happen in a future video, but what we do know is that there are a couple functions that are continuous. We'll want to use this when we're solving these limits. What we see is that polynomials are continuous everywhere, absolute values are also continuous everywhere. Our sine and cosine trig functions are continuous for all real values. Exponentials are continuous over their domains, and rational functions are also continuous over their domains. Let's go ahead and try a couple examples. In this example, we're asked to find the limit of a polynomial. We know that polynomials are continuous everywhere, therefore we can use direct substitution to evaluate this limit. We go ahead and plug in 3, we simplify, and we get our final answer. Looking at this next example, we're asked to find the limit of our cosine function. We now know that cosine is continuous everywhere, therefore we can use direct substitution. So we plug in pi over 2 for x, we simplify and then evaluate our cosine of pi, and end up with our final answer of negative 3. Taking a look at our last example, we see that we're finding the limit of not only an exponential, but also of some polynomial terms. Both of those are continuous, and therefore we can use direct substitution. So we go ahead and plug in 0, we simplify, and end up with a final answer of 0. And there you have it, direct substitution.